Hello everyone, welcome back to another devlog on my Voxel ray tracing engine. This month, I added support to compose the voxels with rasterized objects and developed a UI library to eventually be used in a game. So, one major issue with my engine is that it can only render voxels, meaning that if I wanted to, say, add an enemy for the player to fight, I would have to place and destroy the voxels which represented every single frame, which would perform very poorly. So to fix this, I added the system that allows me to place rasterized objects, which is how objects in most modern games are drawn, within the voxel world. Here, you can see a rasterized cube bouncing around in the demo scene. Once I start working on an actual game, I can replace this cube with any 3D model I want. In order to achieve this, I had to access the depth buffer from the rasterization pipeline, which is a texture that contains how far each pixel is from the camera. The darker a pixel is, the closer it is to the camera. I used this to determine whether the rasterized object or the voxel world should be displayed for any given pixel. In the last two clips I showed you, you might have noticed that the cube seems to just be drawn on top of transparent voxels, instead of behind them. This is because, when checking the depth buffer, I wasn't considering transparent voxels at all. Here you can see that fixed. Since I'm eventually going to make a game, I'm going to need some UI. There are already a ton of great UI libraries out there, such as Dear GUI, but many of these are designed just to be used for debugging and development purposes, and so they just aren't fit for a game. So I decided to make my own. The source code will be linked in the description if you're interested. The first step, as always with any graphics project, was to get a blank window open. After that, I got a simple quad to draw on the screen. I decided to add rounded corners since I think it gives the UI a really sleek look. Next, I implemented basic text rendering using the FreeType library. Instead of rendering text the traditional way, I decided to render it using a signed distance field. Basically, instead of storing the color of the text, each pixel in the texture stores the distance to the edge of the text. This allows the text to scale up really well, and, more interestingly, for different effects to be added. Here are just a few examples of what this allows. I then added automatic line wrapping so that the text only takes up a certain width. I then expanded on this, adding many different rules for the text resizing. The text on the left is set to always maintain its size, and the text on the right is set to scale with its parent size. Every UI element in my library is positioned relative to the screen size, meaning resizing the window doesn't break everything. Lastly, I added an animation system so that I can quickly code in some simple transitions. One more small change I made was to improve the shadow quality, with the cost being that shadows are no longer instant. As you can see here, the shadows fade in over time, but considering the difference in quality, especially on much larger scenes, I think this is a fair trade-off to make. that about sums up the changes for this month. This will likely be the last devlog for a while, as the changes I have planned next aren't really worth making a video about. They're mostly just optimizations and refactors. As soon as those are done though, I will hopefully be able to start making a game with the engine finally. So stay tuned.